Let's start one of the most important topics of middle school mathematics, that's algebra. Now, algebra traces its roots back a long time ago, but sort of the modern father of algebra is Al-Khwarizmi, who existed around 800 CE. And Al-Khwarizmi is a very special kind of a person because you have two very important things named after him. One is algorithms, and this is really how his name Al-Khwarizmi got translated into Latin and then into English. So there's a long story behind it, but Al-Khwarizmi's name got converted through various languages, and ultimately it came down to it got the name of algorithms. So Al-Khwarizmi is directly the person who is responsible for the word algorithms. And similarly, his very famous book on algebra, he wrote a book on algebra, which really has the word al-jabr in it. So there's a word al-jabr in it, and there's a particular Arabic meaning of al-jabr, and from al-jabr in Arabic comes the word algebra. So in fact, both these words, algorithms and algebra, have their roots in Arabic and essentially to one man, Al-Khwarizmi. It's an interesting historical fact. So let's get down to some mathematics and start thinking about algebra. So you've already essentially been doing some very simple kind of algebra. Let me start out very simply and think about, let's say if I say, okay, you have to guess a number, so you don't know what that number is, it's an unknown number, that you add 5 to and you get 7. So what is that number? Well, you've already played that number. You already know this. So this is the unknown number, right? And you will be very quickly able to guess that the answer is 2 because 2 plus 5 is 7. But the way that we formally do it in algebra is that we write this equation down as n plus 5 is equal to 7, where n represents the unknown. And then we say, then remember, and equality is really like a balance, right? So you have to think of this as a balance, and here you have on one side um, you have n plus 5, and on the other side you have 7. That's how you think about it, and they are both equal. The balance is the same. Now what you can do is you can take away the same number from both sides and it will still be balanced, right? So maybe you can subtract 7 from both sides. So if I subtract 7 from both sides, so what do I get? I'm left with n, because if I subtract 5 from the left hand side, I get n. And on the right hand side, I'm left with 7 minus 5, which is equal to 2. So we find out that n is equal to 2. Very similarly, um, if I eat 3 sweets and there are 7 left, so I don't know how many sweets there are to begin with, but if I eat 3 of them, I'm left with 7. So I can think of this as maybe n minus 3 is equal to 7, and then I can add 3 to both sides of the equation. So if I add 3, so I'm now going to add 3 to both sides. So if I add 3 to the left hand side, I'm going to be left with n. And on the right hand side, if I add 3, I'm going to get 10. So I find n is equal to 10. That's the way you think about these problems. Now, we've already worked through a lot of the various kinds of commutative laws. We know things like 4 plus 2 is equal to 2 plus 4. We also know things like 5 plus minus 4 is equal to minus 4 plus 5. We also know things about fractions. So 2 over 3 plus 7 over 9 is equal to 7 over 9 plus 4 over 3. We also know that things like, even if you had negative numbers, like minus 3 over 5 plus 5 over 11 is equal to 5 over 11 plus minus 3 over 5. These are all representing the commutative law um, of addition, right? So, a very compact way to write all these things is you can write it in an algebraic form and say that for all numbers, a plus b is equal to b plus a. And this includes all the numbers that we have on the number line. We haven't talked about irrational numbers, but apart from that, it's very easy to see that a and b can be any number that you want it to be. It could be a rational, it could be a positive fraction, it could be a negative fraction, it could be a positive whole number, negative whole number, it doesn't matter. For all of them, this holds to be true. So algebra, so these sort of variables can very compactly represent what we know about mathematics. Similarly, if you have something like so, for example, what you can have is if you have a square. So just think of a square, and a square has side maybe um, 6 centimeters. So the perimeter is going to be 24 centimeters. If the square has a size of maybe 8 centimeters, so it has a bigger square, maybe it has a 10 centimeters, let's make it 10 centimeters, then the perimeter is going to be 40 centimeters. So this is sort of representing a very general fact, which is, so you can generalize all of that into a very simple, clear fact that if you have a square which has side L, then the perimeter is equal to 4 times L. And that's a very general way of writing the perimeter. The same thing you can do with area. For area, you can write it's just equal to L into L, right? That would be a very reasonable way of writing this. So now let me just briefly tell you something about algebraic notation that we will follow. So it's very common to write, so when we write 3x, it actually means 3 multiplied by x, and what that means is it just means x plus x plus x. So this is a notation. So in general, when we write xy, it really means x multiplied by y. So in general, we just skip out the multiplication symbol, we don't bother to write, and we just suppress the multiplication symbol. When we want to talk about division, so we'll write x over y as a fraction, and this really means x divided by y. And please remember, note that we are talking about something very interesting, that x and y don't just need to be whole numbers, they can by themselves be fractions. So you can divide one fraction with another and write it as x over y. When we have powers, so if we have a power, so when we write x squared, that's a usual notation. It just means x multiplied by x. And when we have, so you can write very compactly something like maybe x squared y. And when we write x squared y, it really means x multiplied by x multiplied by y. And we don't write down the multiplication or the division symbols. Okay, but we do write down the addition symbols. I'll continue this next time, and we'll see how to use this very powerful way of thinking about numbers into doing something very interesting in mathematics.